Okay, let's move on to example number 4. We have a diagram that where A and B are 2 points on a road. So the road is ABC, it's just a horizontal line here or straight line, and S is a spot such that SAC is 35 degrees and SBC is 56. So it is already labeled in the diagram, and SCA is this 90 degrees. And you are supposed to find to calculate the distance AS. So here, okay, this distance AS. So from here, right, if you can see that you need to apply some form of sine rule here with an angle here. Okay, but this angle is not known. Okay, because this is the unknown that we need to find, and it is related to the angle that I have drawn in red. So I can actually find the angle in red here by looking at this straight line. We can see that the angle here, including the angle in red plus the 56 degrees, will be equal to 180 degrees. This is angle on a straight line. So the red angle plus 56 degrees is actually 180 degrees. So I can find the red angle by using 180 degrees minus 56 degrees and get the remaining value there. So I'm going to solve that part of the angle first. So I'm going to find the value of angle ABS. This is the angle that is in red. So that will be 180 degrees minus 56 degrees. So this will give me a value of 124 degrees. Okay, so this is an angle on a straight line. Okay, so I'm going to spell it out. Angle on a straight line. So I will label here 124 degrees. So you can see that 124 degrees plus 56 degrees will add up to 180 degrees. So I need another pair, and I can see that there's a side here 170 degrees, and opposite of this AB is actually an angle here, which is the angle ASB. And after I label 124 here, I can actually find ASB by using the angle sum of triangle. So 180 degrees, which is the sum of the triangle ABS, minus 124 and minus 35 degrees. So angle ASB is equal to 180 degrees minus 124 minus 35. So this will give me a value of 21 degrees. Okay, so once I get 21 degrees, I will update here 21 degrees, and I can form the pair of arrows. So 21 degrees and 170 is now related by the arrow, and you have a cross here, and I can use that to find the value of the distance AS. So this is AS here. Okay, the unknown is AS. So I'm going to put the unknown first. Okay, look at the diagram first. Unknown. So I will put AS, which is the length, over you look at AS related to 124 degrees, so sine 124 degrees, which is equal to 170 over sine 21 degrees. Okay, so this is the sine rule, and we can find AS just by using the method that we have been using. So 170, okay, there's no degrees here. 170 times sine 1 to 4 degrees over sine 21 degrees. Okay, and we press calculator, we should get an answer. So the answer is 393.273. And I'm going to round this up to 3 significant figures, so 293. The units will be in meters. Okay, so it says 170 meters, so that's 170, so the answer will be in meters. Then I can update here 393.273. Okay, so that is the answer to the first part of the question. So for the second part of the question, which is B, there is a slight error here. The perpendicular distance of A from the road, so the road is an ABC here, so you can see there's a perpendicular or 90-degree sign here, so it's not A, it's S. The perpendicular from S, the distance of S to the road, so this is the road and you have an S somewhere there, and you drop a perpendicular line, so this is the dotted line, and you're supposed to find this distance, the dotted line here. So this is the one that we want. Okay, so you can see that the diagram is a bit confusing here. There are so many triangles, so what you can do to see clearly is to do a rough sketch on ASC, because it forms a right angle triangle. So you have A, S and C, and you can copy down the values that we have on the diagram. So AS will be 393.273. you have a 35 degrees here, ASC is 35, and then this is the unknown. Okay, so take a look at the diagram here. This is actually the question that is based on the last chapter, okay, where we learned Tuakaso. So if you look at 35 degrees, this unknown here is opposite, okay, the opposite side, and AC is adjacent, but it's not in our calculation, and what is given here is the longer side because it faces the 90-degree sign, so this is the hypotenuse. So we have O and H, so if we try to fit in the Tuakaso, we are using the so part, okay, because so have the O and the H inside, so we use the sine as the trigo ratio. So sine of 35 degrees is equal to O over H. Okay, so from there we can fill in the value of O, or we can actually replace O here by this SC, which is the answer that we want to find, over the 393.273, H being that value. We can copy down sine 35, and we can find the value of SC. So SC is equals to, okay, so this value will move to the other side. This is a divide by 393.273, so when I move here, it becomes times 393.273. So 393.273 times the sine 35 degrees. So I will press a calculator, this value, and I will get the value of SC, which is what we want. So 393.273 times sine 35. So the answer is 225.572. To three significant figures, I will get the value of 226 meters. So that will be the value of the perpendicular distance.